This is simple harmonic motion example number 4, and we're looking at period of a pendulum now. And for the first one, they're going to have us just go back and do something very simple. And it says you have a tall, thin tree swaying back and forth in the breeze, has a frequency equal to 2 hertz. So we know the frequency here is just equal to 2 hertz. Remember, that's equal to 2 times 1 over a second. Same thing. They want us to find the period. Really simple. Just take 1 divided by the frequency. So that'd be 1 divided by 2. And remember, your unit here is 1 over a second. And this would be equal to 0.5 because it's 1 divided by 1 over a second. You're going to get seconds. And that's all there is to example number 4. Example number 5 and example number 6 have to do more with the period of a pendulum. For number 5, it says world-renowned hypnotist Paul Bear the Great swings his watch from a 20 centimeter chain. So we know that the length of this chain is 20 centimeters. And they want to know, what is the period of swing of the watch? First thing we need to do is go ahead and divide this by 100 centimeters in every 1 meter. And that will give us a length of 0.2 meters. We know that gravity for this situation is gravity on Earth, so we'll just make it 10 meters per second squared. And the equation we will use to find the period of a pendulum is T is equal to 2 times pi times the square root of L over G, where L is the length and G is gravity. Notice that mass and amplitude are not in this equation, hence why we don't use those when we find the period of a pendulum. This will be equal to 2 times pi times the square root of, we said the length was 0.2 meters, and we know that gravity is 10 meters per second squared. Meters cross off, square root of the seconds will give us seconds, and in the end our answer should be 0.89 seconds. So that's how long it would take for that watch to swing from 1 over and then back. And so that would be the period. That is example number 5. Let's go ahead and move on to example 6. It says a spider swings in the breeze from a silk thread with a period of 0.6 seconds. So we know that our T here, which is period, is equal to 0.6 seconds. It then wants to know how long, so we're looking for the length of that spider's strand of silk. In order to do this, we need to use the same equation that we used before. T is equal to 2 times pi times the square root of L over G. Let's plug everything in that we know. We know that the period is 0.6 seconds. 2 times pi times the square root of L, which we don't know, but we do know that gravity is 10 meters per second squared. First thing we need to do is go ahead and square both sides. So we're going to square the left and the right side. When you square the left side, you get 0.36 seconds squared is equal to 4 times pi squared. And then this gets rid of the radical or the square root. We end up with L over 10 meters per second squared. Next thing I need to do is go ahead and rearrange my equation so that I have L by itself. So I'm going to divide both sides by 4 pi and multiply both sides by 10. From here, I'm just going to move over. I get 0.36, and I'll multiply that by 10 and divide that by 4 times pi squared, and that should be equal to L. At this point, we go ahead and do all our math, and we end up with a length of 0.09 meters. And that is the end of examples 4, 5, and 6 for the second section.